Good evening and welcome to another episode of the rest of your summer. Lesson 53 is what you have clicked on. Just be prepared. We're going to add and subtract polynomials. You're going to need a pencil, notebook, homework paper, your brain, solved gear cube. Solved gear cube. All right, here we go. You ready? Let's proceed. So we got to run through some definitions. I got to tell you the language I'm going to be using here. And so you're going to be penciling these things out. You're going to write all the stuff down on the board. And we'll go from there. I'm going to put more up here, but let's start with this. Let's start with a monomial. A monomial. Because we're supposed to subtract and add polynomials eventually. But let's start with just one. Mono means one. And we've got here that a monomial is the product of numbers and or variables with whole number exponents. So let me tease that out just a little bit. First of all, it says the product means that things are being multiplied by each other. We don't need to put a little time symbol there anymore. We're just going to put numbers and letters next to each other, like 3x means 3 times x. We have here and or variables with whole number exponents. So variables are the letters like x and y and z. And we need something else to be there with those variables, and that is whole number exponents. We can have 1, 2, 3. The whole numbers include that set right there on up. They cannot include 0. They cannot include negatives. There's reasons for that. First of all, not 0 because any variable to the 0 power equals 1, and then we don't have a variable. Secondly, if we throw in a negative, that just makes it a reciprocal. That makes it a fraction, and that would be a rational expression. We're not allowed to use those for polynomials. It's a different class of things there if we get into that. So a few things that we need then. We need a product, multiplication, those are sitting right next to each other, of a number and a variable like x, y, or z that has whole number exponents, and then we go from there. If we just have a monomial, we have one term with those types of things all in there together. Second thing we got to do is we got to identify the degree of a monomial, and the degree is the sum of the powers, sum of the exponents of the variables. If there's just one variable, then it's not so bad. X squared. That power there, squared, tells you that's a degree of 2. Okay. Now I'm going to write some out here that are of various degrees. I'll give you the expression. I want you to make a guess. And then I'll tell you how what the degree is of that. So let's start off with an expression here that's made of a number. What is the power of that? What's the degree? Well, there is no variable. The degree is on the variable. It's not on the whole number. It's not on the coefficient, the number that comes in front. So this is something that has a degree of 0. Okay. X. Well, what's the power? What's the whole number power on the exponent of x? Well, it's something here that we'll put here in our little box here is that x equals x to the 1. Y equals y to the 1. Z equals z to the 1. A equals a to the 1. It's understood that there's a 1 power there. Actually, it's also understood that there's a 1 in front of that expression as well. So this is a first degree monomial. You can have more than one variable, and that's okay. We're just going to sum up the exponents of the variables. There happens to be two variables here. And x is x to the 1, and y is y to the 1, and 1 plus 1 is 2. I could write another one here, could have y squared. That's also a second degree monomial. So I'm just going up by powers here. x3 is a third degree, but I could also write something like y squared because I'm adding up the exponents. 1 plus 2 is 3. And maybe I could do another one that's kind of funky. X times y times z is a third degree polynomial or monomial because x to the 1, y to the 1, z to the 1, that's 3. So you can have just one variable like x into a power, and then it's pretty easy to identify it. Or you could have multiple variables, and then you're just going to sum up all their exponents, remembering that if it's just a letter, you can understand that little 1 is sitting there waiting for you to do something with. Fourth degree, let me give you an example of that. I'll throw a number up there in front. We're allowed to do that, the product of a number and a variable. And then how about, let's throw in a different letter. So a means a to the 1, y means y to the 1, 1 plus 2 plus 1 equals 4. That doesn't change anything there. It's just 3 of a x squared y's to give ours a fourth degree polynomial. One more example here. 8x y cubed z squared b. What is the degree of this polynomial, this monomial? What? Oh. That's 1. That's 1. 1, 2, 3, 4, 5, 6, 7. 7th degree. I'll get eventually there. Okay, let's move on to the next thing. And that would be polynomials. Poly means many. And so we had a monomial, which had one term. A binomial is going to have 2 terms. A trinomial could have 3 terms, and on and on and on. Anything greater than 1, you're basically going to call a polynomial, but it might be a specific kind. Binomial has 2 parts, like 2xy plus 3z. Here's a monomial, and here's another one. That's 2 of them. That is a binomial. For polynomials, we want to look for a few things. We're going to be identifying, first of all, their degree. And we're going to identify a thing called the leading coefficient. Coefficients are numbers that come in front of the variables. So that's another thing that we want to identify. And then thirdly, we're going to talk about the standard form. The expressions don't always come in order, and we have to just put things in order the same way we would with place value. We want to put things in their columns in the right place so we can combine them easily. That's eventually what we want to get to. We want to combine these things, one polynomial to another polynomial. The different thing here with talking about degrees is that there's going to be more than one term, okay? More than one monomial in an expression like 2xy plus 3z. So how do you know what the degree is of the whole thing? Because this is all considered to be one thing. Well, the thing here is you just find the one that has the highest degree, and that is the degree of the entire polynomial. So we start doing the math here. We look at this monomial and we go, that's x1 and y1. This is a second degree. And we look at this, and this is just z to the 1, so that's a first degree. But this is the one that determines what we're going to call it. So this is a 2xy plus 3z is a second degree polynomial. Okay, that's the first thing. Or how about, here's another example, 2n squared plus n cubed. Okay, it's got 2 parts, so it's called a binomial. This is a big number, but that doesn't really matter It doesn't matter what the coefficient is to say what its degree is. It's that exponent up there. And this one has the bigger exponent. And so actually this expression here would be considered a third degree polynomial. Okay, now this one would not be in what's called standard form. Standard form decides that we're going to put these things like place value, the biggest thing first, and then the next smallest things on down the line. So I'm going to rearrange this stuff and like this. And if there was more stuff, well, I'd put that next. If there was something like an n, and if there was just like a number on the end. It always has to go from the biggest power, the biggest degree of each term, on down the line. Now, if there's no first degree, that's fine. You don't have to leave a blank there, though I did say it's kind of like place value. It will kind of make sense when we're adding things to keep them in line. But this is a third degree polynomial. It just has more than one term, and we go from the biggest one, and then we go on down. Okay, so two terms, third degree polynomial. Also want to say, once you've put everything in the right order, get rid of that. When you put everything in the right order, the biggest number here first, we look at what's in the front, okay? And I already told you with x means 1x, so there's kind of an understood 1 sitting there in front of n cubed. If it was a 0, then there wouldn't be any n cubed because it involves multiplication here. That number up there in the front is called the lead or the leading coefficient, and it's going to play in to polynomials quite a bit as we go through more math. So that's another thing that you want to identify. The lead coefficient is not 2. We have to arrange these things in the right order first, from biggest to smallest, powers, and then we look and see what number is sitting down there in front, and there is your lead coefficient of this binomial, which has a degree of 3. Okay, here's a few things to do with an expression like this. Give you kind of a run through here of how you approach it. First of all, you want to get it in standard form. So let's identify the degree of each term first. So we got x1 y squared. That's a third degree. This is just a number all by itself. That's of 0 degree. And here we get 3, 4, 5, 6. So we are going to put that part first. Okay, this has the largest degree, so we're going to put it first. 5x cubed y squared z. We're going to put this second. 8x y squared, and we're going to put that one third. So now we've got it in standard form. We identified that this is a 6th degree polynomial. And now that we have it in order, we can look up here in the front and we can find out there is our lead coefficient. Okay, now let's get to adding really quickly, but I think now that we've got all that straightened out, squared away, we should be able to do this other part pretty quickly. A couple things I want you to watch out for, common mistakes on these types of problems. You need to be very careful with negative signs. They have to be combined correctly. Negative means adding the opposite of, so watch out for that. Subtracting one polynomial from another means you're subtracting the entire thing. Each piece gets subtracted. Secondly, this is going to be a lot like combining like terms or adding and subtracting with place value, and I'll show you that as we do an example of one of each. Though because I'm running out of time on the recorder, I'm going to give you these last two examples on a very short video coming up next. Okay, so yeah, come back for more. Lesson 53, part 2 coming up.